Okay, so I hope you can see now the slide on numerical integration. This is the part wherein we evaluate definite non-elementary integrals. Now, the integrals that were discussed under techniques of integration in last midterm are all categorized as elementary integrals. Elementary, so meaning the techniques that were used there and the formulas that you can use will all be applicable to such integrals. Now, this topic of numerical integration is for the evaluation of non-elementary definite integrals. So meaning non-elementary, you will not be able to apply the techniques that were covered last term, okay, last midterm. So then there must be another tool or tools. There must be other tools that you can use. That way you can still evaluate the definite non-elementary integral. Okay. So what are our learning objectives for this particular topic? So you should be able to, so take note of the term that was used, approximate values of definite non-elementary integrals. So they are definite in the sense that they have limits. However, they are non-elementary, meaning that formulas and the techniques that were shared to you last term will not be applicable to these cases, to these integrals. So then what are the tools that we can use to evaluate or to find the value of such integrals? So we have here the Trapezoidal Rule and Simpson's Rule. So these are the two alternatives that we can use in finding the value of these non-elementary definite integrals. However, you have to take note, class, of the term here that was used, approximate. So meaning it does not really get the actual value of the integral, but rather only approximate the value, meaning it will give you a value that is near the real value. But it's not as accurate if you're going to do it using the calculator, meaning directly substitute the limits to your integral using your calculator without showing any steps as to how that particular value was arrived at. Okay, so approximate the values of definite non-elementary integrals using trapezoidal rule and Simpson's rule. And speaking of non-elementary integrals, what makes them non-elementary? So we say that the formulas and the techniques covered last term will not be applicable to such integrals. So I have here examples of non-elementary integrals. So you have sine x over x. This would have been easily integrated if it's not division. If we'll have integral of x sine x, and here for the first slide, please let me know if you can see it. Then we can evaluate it using by parts. If it's written like this, like x sine x. However, in this case, it's sine x over x. So that makes it non-elementary. And no technique that was shared to you last term will work for the evaluation of this. Cosine x squared dx is also non-elementary because of the argument of the cosine here, which is being squared. This e raised to x over x is also non-elementary. X tangent x dx is non-elementary. Cosine of x over x is also non-elementary. This is a common non-elementary integral, the e raised to x squared. The argument of the exponential function is x squared. E raised to negative x over x. 4 raised to x over x plus 1. And the rest here, they are all non-elementary integrals. So even this one, no, x raised to x dx. So this is non-elementary. Though your examples here are indefinite, they don't have the limits. Even if you're going to supply the limits, place the limits here of the integral to make it definite, they are still non-elementary. And as such, of course, we should use the two methods discussed or given in the previous slide to evaluate or determine the value of this integral. Okay? So I will clear my markings here. Yes, John Vincent?
Excuse me. May I ask if where to miss ang encircle mo, miss? Kaya wala siya, I think, ano, sa pag, ano, miss, lang sa kilid, ang encircle.
Okay. Okay, wala siya nag-project, I think. So, what I encircled is this one. The argument of the cosine, which is being squared, that makes it non-elementary. This one, if it had been written here, multiplied to the sine of x, it would have been elementary. The same thing with this, because you can do it by parts. This one is also non-elementary. This one is non-elementary. Here, this is a common non-elementary integral, often used as an example for determining areas under the curve. Another one is this. You see this 4 raised to x over x plus 1. So that makes it non-elementary. And this x raised to x. Although I did not circle the others, but still they are non-elementary. So no formula, no technique that was discussed previous semester will be able to determine the answer to this indefinite integrals. Definite since they don't have the limits. But even if we're going to provide the limits, they will still be, we can still determine the answer. Unless, of course, we're going to use our calculator. But what I mean is you can't determine the answer if you're not going to solve the integral using your calculator. Meaning you are to first present the steps of determining the answer and then afterwards substitute the limits. That's what I mean. But of course, if you're using your calculator can do this easily for you. You just have to wait. You just need to encode the integral and then that's it. Your calculator already has the answer. So that is why when you'll be given assessments later on, you should present the complete solution. Because otherwise, you can have it answered by your calculator, as I've said already. So the steps should be shown. Okay, so these are just one of the many examples of non-elementary integrals. They are indefinite because they don't have the limits yet. If we provide the limits, it's still non-elementary. So we still need to know the topics for today that will enable us to determine the values of the integral. So the process of determining the values of the non-elementary definite integrals is just approximations. So they're not the real thing. They're not the exact value. So in here, we have the trapezoidal rule and the Simpson's rule. So we have the choice whether we have the trapezoidal rule or the Simpson's rule. I'd like to emphasize, however, that in the process of using these two methods, you're going to divide the area under your curve and enclosed or bounded by your limits are divided into n equal parts. So the number of division is n equal parts. Then what makes trapezoidal rule and Simpson's rule different from each other? If both will use division, or like if you're going to cut the area under a curve, you're going to divide the area under the curve in, let's say, 10 parts, then if trapezoidal rule will be done using that, Simpson's rule will be done using that, then what's the difference between the two? The number one difference is, of course, the formula. Trapezoidal rule and Simpson's rule uses a different formula in approximating the area under the curve, though you're still dividing the area under the curve n times. And another one is that in Simpson's rule, the number of division has to be even. You cannot have here odd divisions, like you're going to divide the curve into 7 parts or 5 parts or 11 parts. It's not that. So for Simpson's rule, the number of divisions should be even. So in here, you divide the area into n parts. As to what that n is, it depends on you. The more n you use, the more approximate, rather not approximate, the more accurate is your approximation. So the greater the number of n, the more accurate is the approximation of the area of the curve that could be seen in the given integral. Okay? Now, the n here for Simpson's rule has to be even. For trapezoidal rule, any. It could be even, it could be odd. As long as these n, of course, are whole positive numbers. You cannot divide by a negative number per se if it's area that we're talking about. So here, for trapezoidal rule, it could be odd or even divisions. For Simpson's rule, it has to be even. Okay? So that's their second difference. So that's how you distinguish one from the other. The first, of course, is the formula that is being used. Now, clear my markings here, and we proceed to the next slide. What does trapezoidal rule do? From the term of the rule of the method trapezoidal rule, if this is your curve, it approximates the area of the curve by making a trapezoid on it. So what's a trapezoid? Or you draw a trapezoid under the curve. So it should not go beyond your curve. It should be within the region of the curve. So a trapezoid is any polygon which has two parallel sides. So these are the parallel sides. I'm sure this is how you use or how you designate parallelism in your subject geometry. Is that plane geometry in high school? Or is it trigonometry? But with this symbol, you mean these two are parallel. Whereas the other side, this one here, that coincides along the x-axis, and this one, of course, are not parallel. So it's a four-sided polygon with a pair of parallel sides. That's a trapezoid. So in the case of the trapezoidal rule class, if this is the entire area under the curve, I mean this one, this entire thing, it approximates it to this one. So instead of getting the area of the entire curve or the area below this curve bounded by the x-axis, it will only measure this, the area of the trapezoid. And as such, we use the term it approximates only the area of the curve because this one is not accounted for, this one and this one. So the area that was accounted for is just this part. Okay? Your original function, is this, the one in blue ink, whereas the trapezoidal rule approximation is this one, the trapezoid in red ink. Okay? Then what's the formula that we can use for trapezoidal rule? It's all about the use of the formula class. This is one of the simplest topic, if not the simplest topic in integration. Okay, you just know what the formula is, what are the variables that appear in the formula, and that's it. You're okay already. Now, I'll show to you the formula for trapezoidal rule. Okay? Before I do that, do you have any question here? Okay, there's none. So we go to this one. Okay, this one is one interval trapezoidal rule. We say one interval trapezoidal rule because we approximated the area under this blue curve by just using one trapezoid. And as such, we say one interval trapezoidal rule, meaning you have only one division here. This is your division itself, your trapezoid. What's your formula for this? For the area under the curve using the trapezoidal rule. The formula is this one. I'd like to you to look at this. This is the formula. Never mind the derivation of the said formula, but let's just focus on the formula itself. So you can see here, the integral of the function is equal to, more or less equal to, you see this congruent symbol, equal to the integral of the function of p. What is the function of p? The function of p is that of the trapezoid because the function is that of the curve as shown to you a while ago. So this is the formula. It's h over 2 times the value of the function, meaning whatever is the function here, the integrand. Call it the integrand. You just substitute a to all the variables that you could see there, and that would be the value of your function at a. That's f of a. Then you get also f of b. The sum of f of a and f of b, with a and b being the limits of integration, will be multiplied by h divided by 2. Okay, h divided by 2. So in this integral, a is the lower limit and b is the upper limit. So you just substitute the lower limit to the function here, to the variables of the function only, because the constants, you don't do anything to it. And f of b, the same thing, you substitute b for all the variables, and you take the sum of the two and multiply it to h, where h is equal to the difference of b minus a, and then divided by 2. That's for your trapezoidal rule. Okay, this is your h. Okay, that's it. Now, if that is, if you only have one trapezoid. Okay, my markings, this one is just for one trapezoid. You just cut the area of your curve by one trapezoid. But if you will use two, this one, the two interval trapezoidal rule. The same curve, but this time you had one trapezoid here, and beside that is another trapezoid. Of course, if you would be asked which of these two procedures will come up with an accurate, a much more accurate approximation of the area of the curve, of course your answer will be this one. Because in here, this area and this area is left out. Wala na siya madala, kaya amunin isa lang imo ka trapezoid. But if you use two trapezoids, ano na lang area ang wala madala? Ini, kag ini, but this one is smaller. So the more trapezoids actually that we use, the more accurate is our approximation. The nearer is our approximation to the real value. So your original curve is still this, the f function. This one, you see this f. And you have these two trapezoids here, the f sub p. These two are f sub p, the two trapezoids. The sum of the area of these two trapezoids will approximate the area under this curve f. Okay? Now, this f of x sub 0, this f of x sub 1, and this f of x sub 2, how do you get this one? So that's our next goal. So we go to this part here. It's easy if you have only something like this, because you're only going to substitute a and b to the function. But in this case, you already have two divisions, two trapezoids, so you will not have a simple case of f of a and f of b, but rather you have f of x sub 0, f of x sub 1, and f of x sub 2. Okay, how do we get those? We will proceed. Okay, feel free to interrupt if you cannot follow. That way, this one is an easy topic. You can get this easily, okay, during the quiz, or you can get easily a perfect score here. Now, let's go. So for two intervals, this one is two intervals, we can use summation operation to derive the formula of the two interval trapezoid. That is, you will have now h over 2, and then you have f of x sub 0 plus f of x sub 1. That's 1. You multiply h over 2 by that. This is for the first trapezoid. Ini siya ang una mga trapezoid. For your second trapezoid, you will have, for your second trapezoid, you will have f of x sub 1 plus f of x sub 2. Hindi na siya si f of x sub 1. This is one parallel side plus f of x sub 2. And this is the height of your trapezoid. So what is this? X sub 2 minus x sub 1 divided by 2. Now, why are we using particularly this formula? Because in your high school geometry, the area of a trapezoid, this is your trapezoid. Okay, that's an example of a trapezoid. These two are the sides which are said to be parallel. The area of this is h divided by 2 times a plus b. What is a and b? This is a, this is b, this is h. So the length of the two parallel sides are being added and multiplied to the average of the height. So that's the reason why you have one formula for one trapezoid here and you have another formula for one trapezoid here. Just showing to you how the formula for an nth number of trapezoid division came about. Okay, so in here, if you're going to simplify, you will have f sub or f of x sub o. Then you have this and this, so 2 times f of x sub 1, and then you have your f of x sub 2. You see this? This is now the formula for a two trapezoid interval. Okay, this one, duha ka trapezoid for this area of the curve. Okay, this one. Your h here this time, your h here is x sub 2 minus x sub 0 divided by 2. What is this? Your x sub 2 is your upper limit and your x sub 0 is your lower limit, and then you divide it by 2. The same thing as the this one, the single trapezoid. Okay, let me just clear the markings. Just like this. Okay, you have here, have your f of a plus f of b times h divided by 2, where h is equal to b minus a. Okay, you only have one trapezoid in this case, but that's very seldom, class, that you will only approximate the area of your curve using one trapezoid. As much as possible, we want more trapezoids. That way our area, or the sum of those trapezoids, will be more or less the same as the area of the curve. Okay? Now, in here, if you have 2, that would be it, and this is your formula. Now, how do we make this general? Like, what if you have n divisions? Not just 2, not just 3, but n. I think I still have another one here for 3 intervals. Tatlo na siya ka-trapezoid. So, you have here 1. This was already actually class pre-derived, the formula that I'm going to show to you for 3 interval trapezoids. So you have f of x sub 0, and then you have 2 times the f of x sub 1 plus 2 times the f of x sub 2 plus f of x sub 3. Your h here is x sub 3 minus x sub 0 divided by b. Now, generally, class, generally, this is how we write the formula, and this is the formula that you're going to take note of, okay, for trapezoidal rule. This is the formula. That way, this will work not just for 2 or 3 intervals, but for n intervals. The area of the function is equal to, you get to see h over 2 times, you have f of x 0 plus twice of, you see the summation symbol, this depends on how many divisions or how many trapezoids you use. But this is until f of x sub I. You see this? This is x sub I starting from 1 unto n minus 1. Because for f of x sub n, the last trapezoid, there won't be any multiplier 2 anymore. How would you interpret this? Very simple. Your first term here and your last term here is not being multiplied by 2. All the middle terms, meaning the second term and the second to the last term, will have a multiplier of 2 in trapezoidal rule. Okay? You just make sure that your f of x sub 0 is not multiplied by 2. Same thing with f of x sub n. It's not multiplied by 2. The other functions in between should be multiplied by 2. So you see here summation. Starting from I equal to 1, that is, this one will start with f of x sub 1 until f of x sub n minus 1. So if this is 7, if this is f of x sub 7, then your second to the last term will be f of x sub 6. That's n minus 1. Okay? H here is defined as x sub n minus x of 0 divided by n. Now, this is actually class. The H here, the H that you have, by the way, is this one is the delta x in reference books. How will you increment the x's that you will use here? The true H is actually just your upper limit. Let's say it's b minus a. And then you divide it by 2. The H that is written here is the delta x. The increment, the value of the x that you will substitute to the function here that you have. Let's say we start with f of x sub a, or that is f of x sub 0, which is a, because this is where you're going to start. And the next to that would be a plus this delta x. How do you get the delta x? This is b minus a divided by n. I hope you get my explanation, Again, I will use a different font. I'll clear my marking so it would be clear to you. In the formula that you are seeing here, the H alone, the H is equal to, if your limit here is from A to B, that would be B minus A. And then you just divide it by 2. Okay? That's your H. The H that you see here, the where that you see here, actually it's the increment. I'll cross it and change it. Okay, I'll change it to a different representation. I like to write this as delta x. The delta x is equal to this x sub n minus x sub 0 is equivalent also to b minus a. However, the n here is depending on the n that you have chosen. If you want to divide the area under the curve using 6 trapezoids, then it should be 6. If you want to divide using 7, you can use 7. So this n depends on the number of divisions. Okay, what's the purpose of this delta x? The first that you will have is f of x sub 0, which is just equivalent to the f of a, the lower limit here. Okay, that's your x sub 0. The f of x sub 1, which you need to multiply now by 2 using this formula, will be actually the f of the a that you have here plus the delta x. So if this delta x is 0.1, so the a here, let's say, is 1. So this would be now the f of 1.1. The next would be f of x sub 2. What is the f of x sub 2? That would be the function, again, the a will be added with 2 times of delta x. Now, because what we mean by this class is you're going to increment the value of the variable here in your function depending on this computed delta x that you have. You will start with the lower limit until you reach, using your increments, the upper limit b. That would be illustrated in the specific example that will be shown to you in the next slide. But that's how it is supposed to be understood. Okay? The h, again, in this formula is just the difference of the upper and the lower limit divided by 2. That's it. This delta h that you see here is equivalent to delta x, which is the increment that you will use starting from the lower limit until you reach the upper limit. This value you will substitute to the variables that appear in your integrand. Whatever function would that be, or whatever algebraic expression you have. So the middle terms will have 2. The first and the last term will not have any 2 as multiplier. Now, as to the formula is this. I'd like to erase this one. Okay, I'll get this. So for trapezoidal formula, trapezoidal rule formula, amo lang gina siya. This is the formula. This is the main formula. This is your increment delta x, and this is your h. Okay? Now, I think it will be best if I will go to the example. So, example 1. I project, let me know if it could not be seen so that it will appear bigger in class. Okay. I hope you can see example 1. Use the trapezoidal rule to approximate the definite integral, the value of the definite integral sine of x dx evaluated from 0 to pi. Now, before you even ask a question, ako na lang mahambat. Sa nasiling ka mo, Miss Ali, hindi man na siya non-elementary. True, this is non-elementary. Sine x dx is an elementary integral. It's just being used in here. That way, you will just be able to understand the process, the procedure of how you're going to use the formula in determining the value of a definite non-elementary integral using trapezoidal rule. But as to whether this function is elementary or non-elementary, this one is elementary. It was just being used here for illustration purposes. The main application of trapezoidal rule and Simpson's rule is for non-elementary definite integrals. Okay. So for this example, you are to determine the area under sine of x on the interval 0 to pi using 6 divisions or 6 subintervals, and number 2 using 12 subintervals. Now you will compare the areas that you got here in these two approximations, and of course check which of the two is more accurate. Okay, so here as you could see, A is 0. I just use the red one here. So this is your A, and this is your B. Okay, and
Excuse me, miss.
yes.
I think wala nag-project, miss.
Why could siya project?
Miss.
Okay, then I will try to make this bigger. There. Okay, better. So you have there. Now, okay. This is your A. This is your B. And your function of x is sine x. So the first subdivision that we'll be using is 6. So in here, the h that was computed, that's actually the increment. The increment or the height of each of your trapezoid, not the height of the entire trapezoid, just the height of each of your trapezoid in the number of divisions that you have chosen, which is 6. So in this case, you will have b minus a divided by n. So your b is pi minus a, which is 0, divided by n, which is 6. So your increment class is pi over 6. So you see here, that's your increment. Now your x sub 0, in this case, x sub 0, meaning the first value of x that you will substitute to your function, of course, will be 0. It's going to start with your lower limit. You see this? I'm here on the third row. This is your f sub I. So this is your f of x sub 0. Then you're going to increment starting from 0 using pi over 6. So 0 plus pi over 6 is pi over 6. Plus another pi over 6, so that's 2 pi over 6. Plus another pi over 6, that's 3 pi over 6. Plus another pi over 6, that's 4 pi over 6. Another 1, 5 pi over 6. Plus 1, 6, that would be 6 pi over 6, which is just pi. So that's your upper limit already. The pi that you have here is your upper limit already. So you end with the upper limit. Now, what do you do here? You just get the value of sine of 0, sine of pi over 6 until you reach the sine of pi. So you will have corresponding specific values for this function. What will you do with those? You place it here on the formula. So your f of 0 will be the sine of 0. This is 0. Then after that, you will multiply the function values by 2. So you see here, twice of f1, twice of f2, twice of f3, twice of f4, twice of f5. f6 does not have times 2. It's not multiplied by 2 because based on the formula, the first and the last term will not be multiplied by 2, only the middle terms. So your f of f sub 1 is the sine of pi over 6. With your calculators in radian mode, you get the sine of pi over 6 and then multiply it by 2. So you will have your answer here. Same thing with this. That would be 2 pi over 6. This one would be 3 pi over 6 or pi over 2. This one would be 2/3 pi and so on and so forth. If you're going to add all of this, you multiply it to h. What is the h here? The h is just b over a. It's just b, sorry, not over a plus b minus a. This h here. And you're going to divide it by 2 as per formula. And this is your answer. Now, I'll give you 5 minutes to do that so that you can check whether your answer will be similar to the answer that is shown here. Okay? Can you do that? I'll wait here. Check whether you'll be getting 1.9540.
Miss, our calculator should be in radian mode, di ba?
Oo, radian mode siya. Kaya tungudahin
Yes,
yung angles in radian. Dapat radian siya. Wala kita nag-deal with degree values sa sa sininga problem. Radian siya. Please place in the chat box your answer. Only reflect up to 3 decimal places so we can compare if you're done. Okay. St. Vincent, 11.725.
Yes, miss. Gina-try ko again.
I-check, be. That's too big. Na-multiply mo na sa h divided by 2.
Yes, miss. So
I-check.
H miss pi over 2. Would it be pi over 2?
Yeah, pi over 2.
Yeah, okay. Wait, yes. I'll check again.
Okay. Class, tapos na ang 5 minutes. What's your answer? Is it just John Vincent who's doing the calculating? There's 31 of you. What are the rest doing? $5.86. Okay, Renan got 5.86. Kita sa ako calculator na naka-integrate ko sa jam sa ako. Hindi, amo man yung hinatag mo. Okay, Floyd's answer is closer. Maybe it's not the actual thing there, Floyd, because we cut it off to 3 decimal places. The computation that is presented here is when there's no, when the answer are just being added and added without subsequent rounding off of the values. What about the others? Can you check the actual value? Can you please check the actual value if you're going to use your calculators directly, the integral of sine of x with limit 0 to pi, and get the error. So the error here, according to the what I have used, the values that I placed in here is 2.2951. That's the error of this value compared to the actual if you do direct integration without using trapezoidal rule. Can you please check? So that will not take more than a minute. All you have to do is encode it in your calculator. I can't find my calculator, the one that can integrate, so I cannot help out in rechecking the values I placed there. I misplaced it probably.
Miss, in my calculator, I think it says 2 here.
The calculator has the error of 2.
Yes, miss.
So more or less, that's the error. The error is 2%. What you do when you get to get the error class is, you will get the value of this integral. You get the value of the sine of x dx from 0 to pi. So you will get the value there from your calculator. Let's say this is 1, 2, 3, 4. This value, the 1, 2, 3, 4, you subtract this one, you just need the positive answer. So if it's negative, just make it positive. You need the absolute value divided by 1, 2, 3, 4 times 100. That's how you solve for the error. The actual value minus the value that you got in here divided by the actual value times 100. So your error should be more or less in this range here, 2%. Were you able to get it?
Miss, will the answer be negative?
Hindi siya, kung negative siya ang difference mo diri sa babaw, just get the absolute value because you're just
Okay, miss.
the error. The assign is immaterial. Were you able to get it? I'll give you 2 more minutes so I can finish this topic. It's 2.354. So that's acceptable because you could see here that the error is 2.295. So more or less 2.3. Okay? Thank you for your participation, Floyd and John Vincent. Okay, so that's how you use trapezoidal rule in approximating the value of a non-elementary integral. Okay, so now this is the continuation actually. So you have this one. For the 12, division, so your increments this time, this is your h, so this is your delta x, is divided by 12. So you have pi divided by 12. So notice, class, that you have started with the lower limit, which is 0. Then you increment by pi over 12. So you have pi over 12 plus pi over 12. So that would be 2 pi over 12 plus another pi over 12 here. So that would be 3 pi over 12 until you have 11 pi over 12. You will multiply these functions each by 2. So this should be There should be multiplication by 2 for this. But this one, the sign of 12 pi over 12, which is sign of pi, will just be stand alone. There won't be any multiplier. The same thing with the first term. Your h here is the same as the first example, which is simply pi, because it's pi minus 0 divided by 2. So notice, class, just for comparison purposes, I'd like to clear my markings. So just for comparison purposes, the one that used 12 divisions has an answer which is 1.9885. Okay, 1.9885. The one that used only 6 divisions is 1.9540. Error here is 2.29 or 2.30%. Whereas for the 12 divisions, you have 0.5718%. So the one that made use of more divisions of trapezoids had an accurate answer than the one that used 6. So the more divisions, the more accurate is your approximation. So that's the purpose of this example, having 6 and 12 sub-intervals, where the intervals are shaped as a trapezoid. Okay, that's the trapezoidal rule. So now we go to Simpson's rule. Actually, they're just more or less the same. Only that in Simpson's rule, you're not approximating using a trapezoid, but you're approximating a curve in itself. So this curve that you have here, the original curve in blue, is approximated using these two divisions, but they are curved. Okay, this one is curved as well. So you have one curve here. It's not a straight line. Another curve in here. So these are sides which are said to be parallel. So not a trapezoid, because a trapezoid will all have lines as its sides. This one is curved. Okay, so that's your this is Simpson's rule, using Simpson's rule. So in Simpson's rule, if I go directly to the formula, if it's a one-step Simpson's rule, one-third Simpson's rule, you have this formula here. Okay, I'd like to emphasize what you need to take note of in here in terms of the difference in trapezoidal rule. Your h here, the h here is still upper limit minus lower limit. That is still your h. Okay, the height. Now, instead of dividing by 2 in trapezoidal rule, in Simpson's rule, you divide it by 3. So instead of having here b minus a divided by 2, it's now b minus a divided by 3. Another thing, in trapezoidal rule, you have the first and the last terms having no multiplier. So f of x sub 0 and f of x sub 2 in this case, because you only have 2 divisions, you have only 2 divisions here. So f of x sub 0 is this, f of x sub 1 is this, f of x sub 2 is this. Now, I go back to this one. So you only have 3. So you have f of x sub 0, f of x sub 1, and f of x sub 2. The first and the last doesn't have any multiplier, but the middle term class in here alternates. So what you could see in here for now is just a 4. But actually, if you have more than 2 divisions, what you're going to see here is an alternate of 4, 2, 4, 2, and ends with 4. What do I mean with 4, 2, 4, 2, and ends with 4? These are the multiplier. So your second term will have a multiplier of 4. Your second to the last term should have a multiplier of 4. And it should be an alternate of 4, 2, 4, 2, 4, 2. Second to the last also have a multiplier of 4. The last does not have any multiplier. That's the reason behind why your Simpson's rule requires that your number of intervals or division should be even. It should be even. That way, the way you alternate 4 and 2 here as a multiplier for the middle values of the functions will be, shall I say, in that particular form. So, hindi siya pwede mag-4, dason 2, dason last term. Na? So, dapat 4, 2, 4 yun, and then last term. Okay? So, in here, there should only be even n. So, 6, 8, 10, 12, 4, 2. Hindi pwede 3, 5, 7. Hindi pwede odd. Okay? Your age here, this age here, class, is the increment already. Okay? This is the age in which you're going to increment the x here. So, you start with the lower limit, then the lower limit plus this delta x will be the next x that you will substitute to the function, which will have a multiplier of 4. So the delta x here, class, is x sub 2 minus x sub 0 divided by 2. So upper limit minus lower limit divided by 2. This is how you increment the x in your Simpson's rule. Okay? Now I'll clear my markings. That's it if you have 2. If you have 3, if you have 4, so we don't have 3 because we can't have odd division. So this one is 2 and the next one is 4. So what do we have? So you have here delta x divided by 3. Now you have here, as you can see, 4, 2, 4, 2, 4, 2 ends with 4 and the last does not have a multiplier anymore. Okay? This is your delta x. Your delta x is your upper limit minus lower limit divided by 3. The delta x that you will increment here is solved using this formula here. This is your increment. X sub 2 minus x sub 0 divided by 2, or upper limit minus lower limit divided by 2. The delta x that you see here is just the difference between the upper limit and the lower limit. Now, for you to understand it better, let's have a specific example. So this is an example for determining the value of this integral. Now, this one is a non-elementary definite integral. Hindi siya yan, non-elementary gini siya, kaya hindi gini siya ma-evaluate using the techniques covered in midterm. So you have the integral of 2,000 ln of 140,000 divided by 140,000 minus 2,110 t. Now this is the argument of your ln minus 9.8 t dt. So look at the limits of integration. It's 8 to 30. So if you use Simpson's rule, you have here b minus a divided by 6. So your b is 30, your a is 8, and you divide it, by 6 in this case. Now, this is how you're going to, let me check last what is placed in here. How many divisions was used? The distance covered by a racket in meters from 8 seconds to 30 seconds is given this. Estimate x by using Simpson's rule. So x is being computed, but the number of divisions is able to indicate. Let me check. So 8, 30, and 90. Is this 4 divisions only? Let me check last If I will have a delta x of b minus a divided by 4, that would be 30 minus 8 divided by 4, and that would be 22 divided by 4. So the delta x in this case would be 11 over 2. I was not able to specify the number of division. Let me check Lasa, or from the source I was not able to pick the number of divisions. Probably in this case this is just division by 2 because you only get to see a 4. Let me clear my markings, class. First, let me check the answer here. So only a 4, so there's only 2 divisions in class. So if it's 2 divisions, you have only this, the f of the function a plus b divided by 2. Oh, okay. This one just simply made use of the first formula. This one. Because the number of division is just 2. So the formula that was used, class, in this particular example is just, if you have your cell phones there, is just this one and this. These were just the formula because, as I've said, only 2 divisions were used. So that is why you only get to see a 4. So you don't get to see a 2 and another 4 because we only have 2 divisions. So if you follow this particular formula, so you have already taken a screenshot. So we can go back to the solution and check the manner of substitution. So that's our formula. And we go back to the slide that we're working on. My markings, and we go back to this slide here. But generally, class, if you're going to ask me for Simpson's rule, this is a more general formula. Will work if you have 2, 4, 6, 8, 10, any even number of divisions. This one, where you have already the alternate of 4 and 2 as multiplier in the middle terms. This particular example that was shared to you, I think I took this from a reference, has only 2 divisions. So the formula that we used is just this one. It's just this. Okay? So I'll go to the example. So this is our example. So the formula that was used is the one that was shared. So it's h over 3. So that is why you have here a 6. Because you have here, for the h, x sub 2 minus x sub o divided by 2. I'll place this one. This is specifically, this came from h divided by 3. But h is equal to, based on the formula, x sub 2 minus x sub 0 divided by 2. So you see this 2 and this 3, so it now became 6, and you have b minus a here because your h is actually your limits divided by 2, the difference of your limits divided by 2. X sub 2 is your b, which is 30, your a is 8, and you have divided by 6 because this 2 goes down together with this 3. So you have already 6. Then it should be multiplied to the f of a plus 4 times the f of a plus b divided by 2. This is again formula for a 2 division Simpson's rule. Okay, if you have taken a screenshot of the formula and you have here the f of b. And the a plus b divided by 2 was computed here to be 19. And what was done on the next slide is just the substitution of the values of this a plus b divided by 2, and this b on the function itself. What does this mean, class? Ang a mo ni ba lang nga 8, i-substitute mo di sa t ho. So 2,000 ln of this over this minus 2,100 times 8. Now, after that, this first term, you subtract the product of 9.8 times 8. That's for the A. For the B, instead of 8, you use 30 for the T. So use 30 here. For the middle term, which is to be multiplied by 4, you use 19 for the T. So that's 19 here and 19 in here. That's what is being done in the next slide. Okay, so you substituted here 8, you substituted here 30, and you substituted here 19. These are the values. After that, you just place it here on the formula. So f of 8 plus 4 times of f of 19 plus f of 30. These are the 3 values. The middle value was multiplied by 4, and this is your 30 minus 8 divided by 6. And that's your 22 over 6 times this, giving you this one. Do you get it? Do you understand what is being done? Our formula in here for Simpson's rule is very specific for a two-interval division for Simpson's rule, which is this. Amo naging gamit na formula. This is for two divisions, and this is the formula that was used. Okay? This is the formula that was used. But if you intend to use the general formula, you can check it out. Do it as an exercise. The general formula is this. This will work whether you have 2, 4, 6, 8, 10, and so on, as long as even divisions. So this time you alternate already. 4, 2, 4, 2, 4, 2. Your increments will be this one. If it's 4, then this will be your increment. If it's 5, this should, no 5 because it's add. If it's 6, you just change this to 6. And that's how you're going to increment your y's here, starting from the lower limit. You increment your y starting with the lower limit. So meaning you start with a here, then in here you will have a plus the delta x, the interval. The increment, the delta x, until you reach the y sub n, which will be using the upper limit b. That's how you use Simpson's rule. Now, for you to have an exercise and check on later whether you'll be getting the same values, you use this general formula for this same example. Amo manigyapon ng example, pero gamitan nyo sa general formula. Okay, and then you can message me and check on me or ask me if you have any question regarding the solution that you have. But as for the second example, it was used specifically to illustrate the use of the Simpson's formula for two divisions only. Para lang din siya sa duwa ka division. The general formula was not used in finding the final answer. Okay? I have shared with you in Canvas material which you can read, a document which you can read regarding Simpson's rule and trapezoidal rule. You can read that as well so that it can complement what we have learned, what you have learned this afternoon and what we have discussed. On a final note, using trapezoidal rule and Simpson's rule in approximating the value of the area under a curve will have certain degree of error. And the accuracy is dependent on the number of sub-interval chosen or the number of division. The greater the number of sub-intervals, the closer to the exact answer is the value obtained. So the more you make n bigger, the more accurate is your approximation. Now, before I check the attendance, do you have any questions? No questions? Yeah, stop sharing now.